Have you ever looked up at the moon on a clear night and noticed that it has darker and lighter areas? Uniquely, this discoloration is a result of impacts that inspired the topic of my video today. Hi, my name is Aris Stovall, and today we will be talking about impact craters and how scientists can use them to date surfaces. Impact craters, like the name suggests, are excavated holes in the moon made by impacts between its surface and a meteoroid. Impact craters are important because we can use them to date the moon's surface. No, I don't mean dressing up and taking the moon out to Red Robin, but ascertaining the moon's age. Because it is not always easy to obtain a rock from the moon's surface and chemically determine the exact age of the moon, scientists rely on relative dating by counting the amount of impacts on a surface. For example, say you're at the beach and you're walking further up on the shore. That layer of sand has been exposed longer and has a lot more footprints and debris in it. However, if you're walking closer to the water, there's a fresh, new, smooth layer of land every second that is created by the waves. This scenario can be analogous to the surface of the moon. Logically, a scientist can expect an older surface to have more impacts because it has been subjected to more exposure. By finding the relative age of the most recent surface of the moon, we can then use the moon's age as a benchmark in time to chronologize other events in our solar system. Before we can start counting craters, we must first understand stratigraphy. This four-syllable word simply refers to the properties of layered surfaces. The principles of stratigraphy state that sediment settles in a horizontal pattern, and because of this horizontal nature, the oldest layer is on the bottom and the youngest layer is on the top. In addition to stratigraphy, scientists must be aware that new surfaces are being created all the time. This can happen by craters impacting on top of each other and creating ghost craters. Let's refer to Plato to make this easier to understand. In this model, the moon has 3 layers of surfaces, and the youngest layer, or the pink one on the top, is exposed to craters. One day, a huge meteor strikes the moon's surface and creates a massive crater. We'll call it crater X. Although it takes time, crater X is filled with excavation from other craters and a new surface is formed. Now, the orange surface is the youngest layer. If a scientist were to count craters on the orange surface, they would not count crater X, even though it is still visible, because it impacted on the pink surface underneath it, not the newest layer. Crater X is an example of a ghost crater. Crater counting and surface dating is no easy feat. But with the help of online mapping systems such as ArcGIS, we are one step closer to dating the man in the moon. Thanks for watching.